Hello, my name is Malik and we're continuing our lesson on vectors and bearing. And this time you remember we're focusing on bearing. Remember in our previous lesson we spoke about how to represent bearings and we said we have compass bearing and then 3-point bearing. We looked at the compass bearing and this time we want to look at 3-point bearing. And it says in a 3-point bearing the angles are measured in the clockwise direction from the north pole or geographical north. Note, in a 3-point bearing, we always use three digits to represent the angle. So, a bearing of say 4 degrees is written as 004. A bearing of 65 degrees will be written as 065, right? We always want to see 3 digits. And a bearing of 215 degrees will be written as the same 215 since it's already 3 digits, right? Always remember it's measured from the geographical north. Don't forget that if I have my Cartesian plane, always remember this. You already know. I have to just re-emphasize that. If I have my north, my south, east, and west, here we're saying that it's measured in the clockwise direction. Clockwise, it's always you're going to start from the north and measure through this way. You're going around this way. Going around. Clockwise. Clockwise. You're always going to be going clockwise until you come back, right? And always remember your first quadrant. I want to clean this and do the same thing again. Always remember if I have my Cartesian plane, my first quadrant from the north to the east is always 90 degrees. If I move to the south, this is another 90. So 90 plus 90 is going to be 180 degrees. And then if I move to the west, that's 180 plus another 90 is also going to be what? 270 degrees. We started from 0. So when I move around, this is also going to be what? 360 degrees, right? And always remember you are measuring from the geographical north, right? So let's go ahead and see how to represent them on graphs. So question, we say represent the following graphically. We have 1. Instead of writing just 70 degrees, we say 070. So I'm going to do number 1, 2, 3, and then you do the rest. So let's move on. Let's look at, let's do first number 1 here, right? So our number 1, we have 070 degrees. The first thing I have to do is to draw my Cartesian plane, right? So just as in the compass bearing, I know this is going to be my north. Always measure from the north, right? And I know from the north, if I want to move, I know the first quadrant is 90 degrees, right? And it's saying 70 degrees, and we are measuring clockwise. Clockwise means I'm going to move from this part going towards here. Keep going that way, right? And it's saying 70 degrees. So the 70 degrees tell me that, okay, you're going to be moving only 70 degrees, right? I'm always moving for only 70 degrees. And I know the first quadrant from north to this is going to be east. I know that part is 90 degrees. And I want half of it. Half of it is going to be 45. Therefore, if I'm measuring from the north, it got to be at least more than. I think we even did this. This is almost the same thing as the definition of the bearing. So I'm going to move more than half of it and assume that it should be at least more than half of it. And I'm going to say this is my 70 degrees, right? Just represent here as my 70 degrees, right? So let's look at the next example. The next example is a 120 degrees. So I have to just draw my Cartesian plane, right? I have my Cartesian plane here. And I'm always make sure you have your north and you know you're measuring from the north clockwise, right? I already know this is 90 degrees. This is going to be on the plus 90, which is 180 degrees. This is 270 degrees. And I already have my 360 degrees, and this is from 0, right? So from the 0 degrees, we want 120, right? You want 120. We know from the whole of this to this part, it's 90 degrees. From the whole of this to this part, first quadrant, it's 90 degrees, which is less than the question that has been given you. Meaning I want 120, right? I want 120 because the question given me is to do 120, right? Therefore, I have to now measure. I have to now think about it. If this to that part is 90, how many more or how much more do I have to add to 90 to be able to get 120, right? So I will quickly say, okay, I already know the question that was given was 120. So I'm going to say 120 minus 90, right? 30 degrees, meaning in the second quadrant, the whole of the second quadrant up to this 180. But I want just 30 in the second quadrant. I just want 30 degrees out of this particular quadrant, 30 degrees out of this quadrant to be able to get my 120, right? So I'm going to assume that it shouldn't be up to half of it because half of it is going to be 45. So I'm going to say then moving from this particular spot, from this, maybe up to this particular spot, right? I'm going to say this part is going to be 30 degrees. Just this part, this spot is going to be 30 degrees. And therefore, when I add this 30 to the 90, I'm going to have 120. Therefore, it tells me that if I'm moving from the north all the way here, to this point, that's what I'm looking for. So I don't really need this part. I don't really need the 30, but I only did that to be able to get 120. So the whole of this, up to this part, is what I'm interested in, which is what the question is asking for. So the whole of that is now going to be your 120 degrees, and you are done, right? So only this wasn't really needed, but it was for us to be able to know how much we need to be able to add to 90 to get the 120, which the question asks of us. All right, I hope that is clear. Let's move on. So let's look at the next question. It says 200 degrees, right? So I have to draw my Cartesian plane. I always know I have my north, and I have 90. This is going to be 180. This is 270 degrees. And this is 360 degrees, and this is my 0 degree. And I want 200 degrees, and I'm measuring from the north. So if I'm moving clockwise from this to that, it's still not up to because I want 200. From this to this part is 90. From this to this part is 180. And I'm looking for 200. If I move all the way to this part, it's going to be more than. Meaning it's going to fall within this quadrant. 200 is going to fall within the third quadrant, right? It's going to fall within the third quadrant. So let me first of all clean that. It's going to fall between here, right? So now I know where my angle is going to fall, right? And I'm looking for 200. I already have 180 here, and I already have this as 180. Meaning I need something more to add to 200, right? So I'm going to just simply say the question that was given was 200 minus the 180 that has already been established, 180. And I know I just need 20 more, right? I just need 20 to be able to, 20 from the third quadrant, right? I need 20 from this quadrant. The whole of this is 90, so if I need 20, 20 would just be a small part of it. Maybe I would say, oh, this part is going to be 20. So I know just this small part is going to represent the 20 that I need. This 20, right? You don't necessarily need to write it, but I'm just writing it for you to know that I'm adding this 20 to the 180, right? I'm adding this 20 to the 180 to get the 200 that I'm looking for, right? So I didn't really need this 20, so I can just cross it out, right? Now, so it tells me that if I'm moving from the north, I'm moving all the way from this part to this, that is 200 degrees, and that's what the question asked me to do. So the whole of this is my 200 degrees. That's what you were looking for. All right. Thank you so much for taking your time to watch. So this is what you are going to use to try, right? So you are going to do number 4 and 5, right? And I hope you're going to enjoy it, right? So let's look at if you really if you did the trial work and you really understand the 3-point bearing, then you will be able to understand what you have in your hand now, which says illustration of the position as bearing from an origin. You have this in your handout, and now then you will be able to now understand how this was done. It says find the positions of A, B, C, and D as bearing from O. Right, it's all making reference to the point O, which is the origin, right? And it's saying that the first one, the bearing of A from O, this is the point A. And I want the bearing of this particular A from O, and we always measure from the geographical north, meaning I want to find out the bearing of this point to this point, right? And I know that this is 90 degrees. The whole of that origin will have been 90 degrees. But part of it has already been taken as 30 degrees, right? So if I want this particular space, which is left, this space, that way I've used the red one to mark, then it's going to be the 90, which is the 90 degrees, minus the 30 degrees that is already here, right? And that's going to be what? 0, 6, 0. That's at 60 degrees, right? So let's look at our second example, right? It's telling us to find the bearing of B from O, right? It's looking at this particular point from the point O, which is our origin. And we always measure from the geographical north. So this is going to be our 90 degrees, and this is 180 degrees, right? So I already know that if I'm measuring from the north all the way to this point, it's already 90. If I'm coming to the second quadrant, if I'm moving all the way to the second quadrant, supposing I move all the way here, this is 90, and I move here, this is giving me 180, right? But 45 has been taken as part of it. Right? It has been taken as part of it. This 45 has been taken as part of it. Right? So therefore, if I want to really find this, the red one is going to indicate what we really need. I only need this part. Let's use that. I actually just need this. We actually just need this part from this point all the way to this point. Then to find that, we just have to take the 45 from the 180 degrees. So it's just going to be 180 degrees minus our 45 degrees, right? And that one is going to give us what? Our 135 degrees, right? So here we have 135 degrees, right? So let's look at our next one, which is the bearing of C. The bearing of C from D. All right, so now we're looking at the bearing of C from D. This is already 90. So we already have our second quadrant. Remember, this second quadrant is going to be 270 degrees, right? And we want the bearing of C. So we know that if I'm to move from the north all the way, if I'm moving all the way here to this point, meaning I've turned 270 degrees. But I don't want the whole of that. I just want it to this part. Let me use different color I only want it to this part, from this point to this point. I only want it to this part. which is in this color, the other color. Therefore, if I want that, then it's going to be 270 degrees, which is the total one, minus what has been taken, the part of it that has been taken, which is the 42 degrees, right? I just have to use that. It makes it much easier for you, right? So I already have 270 degrees minus the 42 degrees. So it tells me that that whole turning is going to be 228 degrees, right? So it told me this is going to be 228 degrees, right? So let's look at the next one, which is our last one. Now I'm going to leave the last one for you to do, right, guys? So go ahead and do the last one by yourself, just using the same idea. It's going to be much easier, right? Thank you so much for taking your time to listen to this one. So in our next lesson, we're now going to look at how to do bearing from one point to the other, and it will all make sense when we move into working the distance bearing problems. Thank you so much. See you in the next lesson.